everybody, welcome to another video. Hope you're ready to flex those brain muscles because today we're going to talk about adding and subtracting rational expressions. So we've already been simplifying rational expressions, we've been multiplying and dividing them, and all those videos will be up here if you need to click on those. And now we're going to add and subtract them, which is actually the most difficult of all the operations because we have to find a common denominator. It can get a little tedious, but let's simplify it and let's break it down and see how it works. So first of all, I want to look at this example of adding two fractions. Because if we can relate something like this that looks crazy to something like this that makes more sense, then we can better understand this. That's what I always try to do when I'm learning some kind of new material or when I'm teaching some kind of new material, is always relate it to something the student already knows, right? So how do we add two fractions? We find a common denominator. But what we're going to do in this case is we're going to actually take the denominators and break them down. We're going to do a prime factorization. And what that means is we're breaking this down into different prime numbers being multiplied together. So in this case of 6, it's 2 times 3. So this actually equals 1 over 2 times 3 plus, and in this case of 8, it's 2 times 2 times 2. 3 over 2 times 2 times 2. And why do we do this? Well, for our common denominator, we need to have basically the same thing down here, right? It needs to be our least common denominator. So what do I have here that I don't have here? I have a 3 here, right? So what if I multiply this by 3 over 3? That gives me 2, 2, 2, 3. But now what am I missing here? I'm missing 2 2's, right? So I'd have to multiply this, let me make a little room here, by basically 4 over 4. That's 2 times 2 is just 4, right? So what does my common denominator end up being? 24. Which is exactly what we discussed actually in our adding fractions video. We did a problem similar to this and we found 24 using a slightly different method. But this is a way we can look at it. If you can break down the denominator into a bunch of things being multiplied together, you can see what the denominators have in common and what each one needs to look like the other one, and you can create a common denominator. And that's the same method we use with something like this. This is just two things being multiplied. Just imagine this is 2 times 5 or something like that, right? These are just two things being multiplied, and so is this. And they have one thing in common. They have this x minus 5 in common. So what is this one missing that this one has is the x minus 1. So we're going to multiply x minus 1 over x minus 1. We'll multiply that over here. And then what is this one missing? The x plus 2. X plus 2 over x plus 2. And then we'll have our common denominator, which will be x minus 1 times x plus 2 times x minus 5. We just have to finish working this out. So that's how we're going to use, that's how we're going to find our common denominator. But the thing is that's special about this problem is that it's already factored for us, right? It's already set up as two things being multiplied in the denominators. And in most cases, it will not be factored for us. So that's the trick, is it's just more factoring. You get to practice more factoring. And yeah, that's pretty much all it is. You factor and then you factor as much as you can in the denominator, and then you look for what they have in common and what you need to multiply each expression by to get your common denominator, so that you can, once I have this, I can just add across and combine everything into one fraction and then see if I can simplify. So let's go ahead and do that. Okay, so let's go ahead and get started with this first example. Remember the first step, we want to factor both the denominators as much as we can so we can have an easier time finding our least common denominator. So let's go ahead and factor this denominator. This is actually a difference of squares, right? So I can express this as x squared over x minus 2 times x plus 2 times x plus 2. And this is minus 2 over, let's see, well I still just have x minus 2. I can't factor that any further. So, and anytime there's just one thing down here, I can just throw parentheses around it. Same thing, right? It makes it a little easier to look at. That's just what I do. So I have an x minus 2 and an x plus 2 here, and I only have an x minus 2 here. So in this case, it's actually a little bit easier of an example because we only have to modify one of these expressions. So I'm going to go ahead and multiply by x minus 2 over x minus 2, because that's going to, I'm sorry, x plus 2, right? X plus 2. That's going to give me what I need as far as the common denominator. So what does my answer look like now? I still have this x squared over x minus 2, x plus 2. And now I have minus, and I'm going to go ahead and distribute this 2. I'm going to do minus it's going to be 2x plus 4 up here. 2x plus 4 over x minus 2x plus 2. All right, let's make sure that's right. 2x plus 4, yep. Okay, so now what I do is I subtract across, but remember this negative needs to go to everything in this numerator. So just imagine a little parentheses around this, and it's minus 2x minus 4, right? So what I'm left with actually is x squared minus 2x minus 4. And on the bottom is x minus 2, x plus 2. And depending on your professor or what class you're taking, this usually is a good answer, but sometimes you do want to check and see if you can simplify even further. Like if you could factor this down to cancel out maybe an x minus 2 or an x plus 2. In this case, you can't. You'd have to use the quadratic formula, and you can't. So in this case, this is the final answer, but depending on your professor, ask your professor how far he wants you to simplify. But all right, let's go ahead and do this last example. So we're going to try to factor the denominators first off. So we're going to factor this. This is a quadratic. Let's see, the leading coefficient is 1, so I can just use my multiply add method. I need two things that multiply together to be 2 and add together to be 3, right? And I think that's just 2 and 1. So that actually factors to x over x plus 2, x plus 1. And if I want to check my answer, I can always FOIL that out. All right, what about this? This is a difference of squares. 1 is still something squared. 1 squared is 1, right? So this can be simplified to, factored to x minus 1, x plus 1. So here I have x minus 1, x plus 1. And let's see, that 2x minus 3 is still up top. So now what do I have in common here? And this one I'm missing an x plus 2, right? Because they share an x plus 1 in common. So I'm missing an x plus 2 here, and I'm missing an x minus 1 here. So I'm going to multiply this by x minus 1 over x minus 1, and this by x plus 2 over x plus 2. So let's see if I can go ahead and do that, if there's room here. So I'm going to put the x, what am I putting here? X minus 1 here over x minus 1. Sorry, it's a little messy. And then this is x plus 2, x plus 2, and the x plus 2 is on top. I'll rewrite this nicer in the next step. Let's go ahead and do that. Okay, x, I'm going to go ahead and distribute this. X times x is x squared minus x times negative 1, which is just x. So x squared minus x is up top there. X squared minus x, and on bottom I still have that big thing, x minus 1, x plus 2, x plus 1. And this is being added plus. Now I'm going to go ahead and FOIL this out because this is multiplying to this whole thing. So I got to FOIL this top guy. So 2x times x, that's 2x squared. 2x times 2, that's 4x. Negative 3 times x, that's minus 3x. And negative 3 times 2, that's minus 6. And that's still all over x minus 1, x plus 2 times x plus 1. Okay, so now I just have one more step. In this case, it's addition, so I don't have to worry about distributing any kind of negative or doing anything like that. So I can just add across and combine my like terms. In this case, it's going to be x squared plus 2x squared. That's going to give me 3x squared. So this equals 3x squared. And I have minus x plus 4x minus 3x. That's actually minus 4x plus 4x. That's 0, right? These three all cancel each other out. So I already got my x squared. So all I'm left with is minus 6. All right, now what do I have on the bottom? Still that x minus 1, x plus 2, x plus 1. And you could factor out a 3, but it wouldn't help you, right? Because it would just be 3 times x squared minus 2. That x squared minus 2 isn't going to factor any further. So this, I would say, is a good final answer. But again, always ask your professor and see what they prefer, how far they prefer you to simplify, that sort of thing. But hopefully you enjoyed the video. Make sure to like, comment, subscribe, do all that stuff. Visit our Facebook and Instagram page, and keep flexing those brain muscles, keep making those brain gains, and I'll see you in the next video.